Okay, welcome ladies and gentlemen, and good afternoon, and thank you so much for joining us at our Data Bytes series as of today. Data Bytes is a kind of a lunch and learn format that we do online on several great topics. Today's topic is industrial data science. You know, the integration of data science methodologies within industrial processes is very important. It's leveraging advanced analytics, machine learning, and predictive modeling in order to harness the potential of data generated by sensors, machines, and production lines. And for that event, I have the honor and the pleasure to introduce Linus Kohl. He is a research associate of the Institute of Management Science at TU Wien. And he also works with Fraunhofer Austria Research since September 2019 and heads there the group for production optimization and maintenance management. He studied mechanical engineering and management at the Technical University in Vienna, and he focuses on the field of data-driven maintenance and the use of artificial intelligence-enhanced assistance systems in production. Linus, very welcome. Great to have you here.
Thank you, Johannes. Thank you.
I know this is a brand hot topic. We had a lot of people register to listen to that, and we also have then afterwards actually some training opportunities that you might explain in detail. We're looking forward to that. There's nothing else that I can contribute any more than saying thank you so much, Linus, for doing that, and please go ahead with your presentation. Thank you.
Yeah, thank you very much, Johannes. Thank you for the opportunity to present you industrial data science and the IT manufacturing course, hands-on data science for practitioners in industry. But let me first introduce shortly, as presented by Johannes, I come from Fraunhofer. What is Fraunhofer? Fraunhofer is Germany's and probably world's biggest applied research organization, where we focus on industry and technology research, applied research for advancing Europe's industry and business. Fraunhofer has more than 30,000 employees worldwide. We are talking about nearly 3 trillion euros of research budget. Fraunhofer Austria itself is a fraction of that. We have now around 130 employees in Austria and a bit more than 8 million euros of research budget. We have two main centers. One is in Graz and Klagenfurt, where my colleagues focus on digitalization and artificial intelligence, as well as visual computing. For example, the Viennese central station was visualized in 3D before it was built in order to, for example, see how people will go through this building, see this building, and therefore you can get the best emergency routes, best how attention markers where people should go, as well as the best advertise areas, which are the highest costing ones, because people look at them. We at the Center for Sustainable Production and Logistics focus on where should you build a factory or a warehouse, and then we go down and look at how this factory or warehouse should be designed, where should be put which machine, what are the material flows through the working areas to the machine until the machine, where how we can optimize this machine, how we can increase productivity, increase effectiveness of a certain procedure, until to the microscope of how we work with the machine. And that's also where I and my research group are working on, that's optimization of machines, plants with predictive maintenance, therefore the use of artificial intelligence in order to get more deeper and better insights than with traditional methods. But that's enough about Fraunhofer itself. Why we are talking about industrial data science? We are talking about industrial data science because at the moment, a lot of companies, like 73% of them have currently no clue why they are doing it, or what they should do. Sorry, this should not happen. Why they should implement artificial intelligence in their company. Most of them are just in the planning phase. About 80% of structure in the companies at the moment is unstructured, and only 20% is structured. But these 20% are sensor data. And mostly when we talk about predictive maintenance, people talk about sensor data. So there's an 80% of untapped data in those companies. And of those, mostly sensor data, only 30% are used at the moment. 70% are unused, as recent research studies have shown. And therefore, in Germany, Austria, or Europe itself, we have high production costs, where, for example, maintenance makes 15 to 60% of it. And our goal must be to cut them to probably 20%. And Gartner came to the conclusion that by 2025, 35 to 50% of all companies will need vertical and horizontal driven data analytic solutions. But at the moment, most solutions do not focus on the humans in the process and don't build human-centric AI solutions. And that's one of the main goals where we as industrial data science can tackle industry problems in the lack of AI solutions built for industry, for the workforce there, which can assist them. That's the big picture from the side why we should do it from an industry perspective. But why should you as a person learn how to use industrial data science? Simply because there's a high demand and career opportunities. There are a lot of jobs out there looking for industrial data scientists. Here I got one screenshot from the American Institute of Labor, where they see that's one of the highest rising job markets at the moment. And it's also one of the best paid ones. So there are a lot of career opportunities, and there's a high demand for them. You will dive into the world of data-driven decision-making. You can use your domain knowledge, for example, as an architect, as an engineer, in order to make data-driven decisions about certain problems. That's a skill you can not only apply to industrial data science, you can apply it to a lot of other areas. Therefore, it's a competitive advantage and skill set. And which people often forget, that you have a very high impact on innovation and sustainability. Industrial data science, as I said before, focuses a lot on how to increase, for example, productivity, effectiveness of machines and processes. Therefore, reduce energy consumption, reduce resource consumption. And in this course, you will learn the skills, how to evaluate first of all, or make transparent the energy usage, for example, of a machine, of certain process steps, and therefore will be able to increase the sustainability in the long term of such a project. But there are also even more interesting applications. You can build a recommendation system for materials, so that if there is a more sustainable alternative for a certain material in the design process. And also you can reduce failure in the building process, and therefore, for example, in the case of factory, reduce the amount of resources wasted on a certain step. So for this, why you should learn, and why the industry needs people like you, how we can help you to achieve this, is by our industrial data science course, which has 3 levels. The beginner level, the foundation level, where you focus on object-oriented programming with Python, learn how to apply statistical methods, and also visualizations, and making processes transparent, making machine usage problems transparent. The practitioner level dives more into the topic of machine learning, and the expert level then really focuses on how to use certain deep learning methods in the design process. But more to this later on. Who is our target audience? We mostly focus on people with a certain background, skill set, domain knowledge in an area, for example, business analysts, industrial, mechanical, or civil engineer students and alumni who have knowledge in their domain, know how to know the problems and probably the classic solutions to this, but at the moment do not have the programming skills or data science skills themselves to solve those problems with artificial intelligence. And therefore also practitioners without knowledge of data science. So in this course, we will together take the journey from your domain knowledge in the end to a certain industrial data science skill set, which you then can apply to interdisciplinary cross-domain applications. So the question is, okay, nice course names, nice target audience, but what will you learn in those steps? You will learn in the beginner course how to understand the basics of object-oriented programming in Python, how to apply statistical concepts in Python, and being able to apply fundamental concepts of them into Python, and then perform basic data analyzations and visualize them and draw conclusions from them, which is, in most cases, the most important part of any data science project. If you focus on the CRISP data mining model, which you can see on the right-hand side, business understanding, data understanding, this makes up to 70% of your time in an industrial data science project. You have to understand what is the problem from industry perspective and from the data perspective. And in the beginner course, you learn how to do the basic steps in Python for the data understanding. In the intermediate, you will learn the whole CRISP data mining approach, how to apply them to different projects. You will work with this methodology, and then you will build models and evaluate models. You will learn supervised and unsupervised machine learning models and apply fundamental concepts. You will learn to interpret and evaluate the results of those models, and you will also get the background knowledge to understand the fundamental mathematical concepts behind artificial intelligence and to understand the possibilities and limitations of artificial intelligence. A lot of people talk about artificial intelligence itself, want to solve everything. I was some hours ago in a meeting with a company contact, and we can solve this with AI, but there is always at the moment also a limitation. We can't do everything, but some things we can do excellently. Therefore, you will learn how to what can you solve with artificial intelligence and with which method in an industry context, which is probably one of the best skills you can get. And in our advanced course, you will learn to apply AI algorithms and models to architecture, engineering, and construction industry problems. For example, you have a sketch and want to create a 3D model, even into a virtual reality application, but how to get from sketch to 3D VR model with a certain set of AI algorithms, mostly deep neural networks, which generate you 3D models out of them. So you will learn how to create those deep learning models, but also the optimization, as you can see here, the data set of buildings and sketches. When you have a parametric 3D model, you can easily adjust them to new demands of possible customers or processes. So you will be able to understand and apply the knowledge of deep generative networks on a given state-of-the-art architecture, engineering, and construction problem. That's the main part, what you will learn in this course, in our 3 parts. But before we dive into what what examples we will show you and what you will be able to solve at the end. Let's start with a short definition about a classification of artificial intelligence until what are large language models. Artificial intelligence itself is multidisciplinary and is concerned with the development and systems and techniques that enable computers to perform certain tasks which require human intelligence. Here, the aspect is human intelligence. We talk about strong AI, weak AI, and what are their applications here. Then we will focus on machine learning, which is a subfield of AI, and how their main algorithms work and how to build those models. Deep learning itself is also a subset of machine learning, and they are built on artificial neural networks. So we learn about the architecture of artificial neural networks, and we learn how to apply certain architecture types to different problems and gain insight and into them, therefore the advantages and disadvantages for a certain application. We will also learn how to use natural language processing, which is a subfield of artificial intelligence itself, uses a lot of machine learning and deep learning technologies in order to solve certain problems. And natural language processing deals with the interaction between computers and humans in human language. So we will learn to analyze human written texts and use them for forecasting and certain predictions. I will show you later. And as we are at the moment at the time of ChatGPT and all the other large language models and chatbots, we will show you what are large language models, how they basically work, and what challenges you can solve with them, and what are their basic difference between current or past language models. So you see, you will get a broad overview from a technical perspective, but also from a domain perspective. And that's what I want to show you here really, because the most cases you want to know what can you do afterwards. What is the key takeaway of such a course? What can you solve with it? Here I want to give you 4 main practice examples of industrial data science. I will show you with which problem we started, which steps we took in order to accomplish the final product. Once is a fault documentation, we stay in the area of maintenance, and I will show you how which tools we learn to solve problems in maintenance, in industrial maintenance, how we can support those maintenance engineers with information, with the right information in the right format for solving certain problems. Then we will take the next step and see how can a maintenance chatbot use those kind of information and even enhance the experience for the user and make a better workflow. And then we will dive into a related but similar topic, which is AI-based spare part management, which gives you an idea how we can solve, I can tell it, the spare part problem in industry where the so-called core data is very bad, and we talk about how to improve the master data in companies in order to make recommendations for a buying process, but also for the maintenance process with spare parts. The last part will be how AI can be used to change the design process of factories, what we can achieve here, and what you will learn in order to solve common industry problems, not only from factory design or warehouse design. You can apply this technology and knowledge to nearly every other design domain. But let's talk about fault documentation 4.0. So what is fault documentation? The biggest challenge in industry is there is a lack of solution for documenting and resolving maintenance support. If we focus on Europe, we have a declining workforce. We have less and less highly skilled people, but on the other side, the demand for such people rise and rise. So we have a knowledge problem. So we want to present people past knowledge about certain maintenance tasks and want to help them with the right information. And at the moment, especially the troubleshooting process is very lengthy and causes a lot of trouble for those maintenance engineers. As well, it's normally done on a bulky local application on the terminal PC, which leads to unsatisfactory results in the documentation process. So you will learn how to clean data. You will work with language data. You will work with numerical data from manufacturing execution systems in order to build models for, first of all, prediction of so-called mean time to repair. So the time between the machine goes down and the machine goes up. So how long the maintenance technician takes time to solve the problem. You will you will learn to clean maintenance report data in order to create a standardized wording framework, which then can be used for recommendation of root cause problems and therefore tasks which solve them. On the right-hand side, you see such an application in use. You will not learn how to build the web interface, but the algorithms behind, you will get an understanding how to build such a rating system, how to apply a large language model like GPT-3 or Llama 2 to such a problem. What are the limitations? What can such a model solve at the moment? And what can it not solve? We all use ChatGPT and we sometimes think, yeah, that should be no problem. But if you look at industry data, which is far more messier than like a random book from the internet, you will see what are the problems here, what are the limitations, and which part still needs a lot of manual work to improve the data quality. So classic challenges in industry. And you will learn the data science tools for this in combination with your domain knowledge. You can transfer this probably to any other domain, let's say construction of buildings, where this, what you can see at the moment, was more or less designed for the automotive industry. You will learn how to use responsive web applications with customized setting, and you will dive into the topic of knowledge graphs, how you interlink data. Knowledge graphs are more or less a different form of database, to be very easygoing on this topic. And there you can connect different knowledge nodes with each other via their relations. And you will learn to build such a knowledge graph and how to leverage information stored there and how you can use this in combination with any large language model. Based on this, with this knowledge, you can build a chatbot. Once again, in big companies, you have the problem with the lack of overview of existing knowledge in companies. There are a lot of knowledge resources which are not tapped at the moment, are not connected. People use different kind of applications and use a lot of time just for collecting information, typing information from product A to B, checking information somewhere different. And a chatbot can incorporate those informations. You will learn how to link systems, how to make statistical analysis over different information sources, how to predict certain KPIs, let's say remaining useful lifetime for certain machine components in another machine learning model, and use this, for example, in a chatbot in order to make better predictions when and where to take certain maintenance tasks. So therefore, you build machine learning models, you once again apply large language models, but this time in a different context, and you will get a glimpse into what is reinforcement learning for human feedback, how you can use it to even more improve the current chatbot, so like a self-learning system, which is one of the biggest challenges in industry, that sometimes you build a system, a great system, in a year X, and in a year Z, sometime later, you have totally different machines, and the system did not change and did not evolve with the model. And we will learn how to tackle this, how humans can give feedback to machine learning algorithms, and therefore, in the long run, can help to improve those algorithms. In all these projects, we follow the crisp data mining circle, and therefore we will see and learn how to apply certain steps, how to evaluate such a chatbot. For example, in the case of chatbots, the evaluation of their outcome is not that trivial as, for example, or easy. Let's say in both cases, it's not trivial, but easy and transparent with, let's say, a linear regression model where you have, let's say, housing data, which is a famous data set in data science, and you can't compare housing prices as easily, the result of the algorithm, with how good is an answer of a chatbot. How good is an answer is a very hard to grasp concept, and you will learn some very practical tips and applications how to do this, how you can learn how to interpret answers of chatbots and how to build a benchmarking data set, for example. Yeah, and then probably one of the most important industry use cases is the poor master data situation in companies. You have a lot of companies, especially big companies, who have a lot of plants, machine, even factories, but the master data situations, like which a spare part has certain, comes from a certain company, has a certain size, dimension, and even material. And you could build great recommender systems just for them. But normally the master data does not allow such a recommender system, because the system itself lives from human input. So therefore, we have messy data. Always when humans input data, you normally talk about messy data, lacking data, missing writing styles or different writing styles. And you will learn how to deal with that. How you can impute, for example, the volume, the material, or the weight of a certain spare part. Even properly recommend who built this spare part, or who is the supplier for them, how long the supply will take, how much it will cost. And we will show you what ways, for example, via API are there to incorporate those master data back into an ERP system in order to make predictions, for example, in the buying process or the maintenance process. So you will learn to import master data from an ERP system, clean them, evolve them, and map them to a knowledge graph, how to build a knowledge graph, how to build relations between different spare parts, and then build a recommendation system, how to compare those solutions. In the case of this GIF, you can see here, it's how to recommend spare parts from one plant to another plant with different machines. So you will learn similarity metrics. You will learn how to build such a recommendation systems on what weights, etc., are used in such a system in order to make good predictions, or even then cluster your predictions and recommend the maintenance technician, for example, a whole spare part system, where they say, okay, let's take this one. So you will also learn the commercial perspective from such a spare part objective. Because in industry, normally what you have to understand is why you do a certain step and what often in the sense of cost or another KPI do you gain from forecasting spare parts, giving recommendations on maintenance tasks, etc. Therefore, most of these projects and tasks you will learn in those courses focus on a an interdisciplinary approach between domain knowledge, data science incorporated into one big challenge. So like the challenge you will work on will probably be not the whole process, but you will learn, for example, how to optimize the runtime in a certain process in manufacturing on one workplace, then for 4 workplaces, and see which step was the most time-consuming step, also in the sense of quality, for example. So you will learn how to interpret different business goals in contrast to the data science goal behind it. Because sometimes you can build great models in data science. You can build, for example, a chatbot application for a certain use case, and it would be great, but is it really worth it building such a thing? So you will learn how to interpret those challenges. And we will focus on application-oriented knowledge. What are classic industry use cases and what we can deliver here? As well, how can artificial intelligence change the design process? At the moment, if you want to build a new factory, you first of all plan it, make probably a rough layout dimensions. You plan on what you want to, what you want to produce, but which quantities, etc. And it's a very lengthy process. And on certain steps, you need information for example, the government. You need them to show certain plans. Or you need your customer wants to get a visualization how the factory or the warehouse should look like, where should the machines be placed, and how much greenfield they need for the new factory. So you will learn how to start from sketch, not from scratch, from sketch here, and generate 3D models. And when you have the 3D model, it has certain parameters, let's say length, depth, width, and they have all a certain impact on another, let's say KPI, let's say costs. And I tell you as a customer, I want in this amount of costs, I want to have the longest possible, let's say, steel beam. You will learn how to build algorithms who can optimize for certain KPIs, not just one, but theoretically infinitely many KPIs, and how to render such 3D applications out of it, which is mostly done by deep neural networks. And those optimization algorithms and knowledge about deep learning is a very sought after skill in industry, because the whole design process, there are probably thousands of people in Austria involved just in building 3D sketches every day for houses, flats, any construction material out there. But in the future, and that's what you will learn, like the skills of the future, this could be done to some degree by artificial intelligence, which can streamline the construction and design process. And you can have very different discussions with your customer how to design a certain object, if you can show them with one mouse click not totally, but a different object with different capabilities. Let's say a warehouse, you can decide how broad it will be, but then you have to do the mechanical calculations for the beams. Such a model can incorporate this via their optimization algorithms, and then derive a 3D model via deep neural networks out of them, which you can access, for example, with VR goggles. So it's the interdisciplinary cross-functional approach we will show you, how to solve very different real-world problems with relatively known tools, but their interconnection and combination is what makes industrial data science so interesting. So like why you will learn this, and we will show you how to apply data science knowledge and often very basic understanding about machine learning algorithms is enough to solve, for example, such a master data problem. Because when you can augment data, impute data, you have 40% of the whole project done. But these parts, therefore you need the right tools. We will show you, and we will show you how to apply them in a real-world setting. You will work on those settings, first of all, in single person assignments, but also in collaborative settings via our high-performance computing cluster. Therefore, we have different industry use cases for you. We will show you the basics, show you on hands-on examples how to apply them, and through those courses, we together will grow in potentials of application together and learn how to become, or we will become, industrial data scientists based on the domain knowledge integrated with data science know-how. Yeah, I hope those examples made you want to join our course, and yeah, I'm really looking forward to your questions. I'm happy to answer all of them, and even more happy to see a lot of you in our course this November.
Well, thank you so much, Linus, for this exciting presentation. I'm really looking forward to those trainings. For all of you being online, if you have a question, there are 3 ways to do that. You can put it, if you go down and look at the Zoom bar, you see Q&A, you can put it in there, you can put it in the chat. Or if you're really brave, you go to reactions, you raise your hand, and you can talk to Linus directly. We do have one question in here, and that is from Jessica, and she's saying, I'm currently in my 2nd year in master's degree in data science, would say that it gets a lot more complicated as we go deeper in each lesson. I'm also preparing for my thesis study for the next year before I graduate, since data science is a very large field. What advice can you give me as a student, as an aspiring data scientist? I think she wants you to narrow down the field a little bit.
From my personal learning experience, what I can really advise you to is find what makes what's interesting for you. So like, where do you have in the whole field of data science, where's your passion? Let's take me. I studied industrial engineering, so like I come from the domain, and then I started it was 10 years ago at the University of Vienna, TU Wien, as first of all as a student, then as a big data engineer. And through this process, I learned that combining data sources sounds strange, but it's what I like. It's graph databases, so like knowledge graphs. That's where I come from. And from there, I came to the topic natural language processing. And then there was the next step. I found the domain to apply it, which was maintenance for me. And that's in a nutshell what my learning experience is. I found a passion in this field for me. I find it fascinating. I dived into it even deeper. And then I found an application where at the moment, that's especially in research, where at the moment, no one really was working on this. So there was a gap. And yeah, all the tools you see beforehand have to some degree a combination with natural language processing and knowledge graphs, because that's where I come from. I still find it, yeah, even if you use just Facebook, you see a knowledge graph because that's in the background. So there are so many applications, but as you can see, you have to be enthusiastic about it. And if it's humanism, digital humanism, get into it. I have a colleague of mine, she also studies data science, and she says, yeah, she likes diving. She likes, let's say, the whole marine world, and she wants to change that. And so she gradually dive into the field of data science for marine habitats. And for example, here you can use image processing in order to detect illegal fishing. So you have to find your passion. And when you have your passion, you will learn the tools easily. And that's probably the biggest tip I can give you. In the whole field, data science, which is big, find your passion. And your passion must not be some industry stuff. It can also be like diving. You like animals, you like them. Find that and then go deeper there.
Yeah, there are many opportunities. My oldest son, Michael, works in New York City, worked for JP Morgan, is in the finance business. And he's now head of research at a hedge fund. And if you are interested in finance and doing research and prognosis models in hedge funds, that's a great way to use your data science knowledge. So, yeah. And they are getting paid well, just in case you are. Thank you, Linus. We have another question here from Bhaskaran. I hope I pronounced that right. Are there any specific products or softwares that you will use to train them during your courses, Linus?
All of them will be provided by us. So we will use a platform from Tilvin, which is a Jupyter Hub where a lot of software is installed. So if you're familiar with Jupyter Notebooks, everything is fine. If you don't know them, you will learn how to use them in this course. Absolutely no problem. And everything we will use during this course is web-based, and you will get the access codes from us. So don't worry about certain products. But if you want to work with them beforehand, let's visit Anaconda, download Anaconda. There is a Jupyter Notebook you can start. You can play around with Python, no harm done. And the knowledge graphs will be done in Neo4j because it's very easy to use. There are great instruction videos out there, and it's easy to handle and very user-friendly, in my opinion. But there are out there a million tools. And I believe when you work with them more with time, you also learn which is your your biggest favorite in case of tools, depending on a lot of parameters. I hope this answered your question.
I think so. If not, Bhaskaran, just let us know if you have any more in-depth question. In the meantime, I'm going to ask you a question. You know, it seems so surreal that you talk about hands-on practical learning and do that over Zoom. How are you going to assure that the people actually do have a hands-on approach there?
Yeah, there's this project, problem-solving, problem-based learning approach. The Jupyter Notebooks, you will learn theoretical stuff. You will learn how to, let's stay with basic Python programming, how to build a function, how to build loops. And then you will apply them, first of all, on a practical level, but without domain context in your Jupyter Notebook. And in the next step, you will get a practical example where, for example, you have to calculate the runtime of a machine. And for solving this challenge, you need, for example, a loop, a for loop. And in the next step, when you have more knowledge and you have to do analysis, for example, based on a production line, which line performs better, or what is the mean time to failure in a certain line, you will be paired in teams, work collaboratively on those notebooks, and solve, in this case, a real-world challenge. All these challenges we will see in the course, to some degree, have an industry background, come from a real-life industry problem we encountered during our time in applied research. Therefore, we have done it, we have been there, and learned through those challenges, and we believe that you can also learn from those challenges, because that's what you encounter in industry normally.
Okay, very good. We just got a chat that obviously the coupon early bird does not work. There comes an error message at registration. I'm just going to ask my colleagues to have a look at that and fix this. We also have a question from Malcolm, but I think that's better answered through a message in the chat, which is what are the costs and how long is the course. Yes, so I have another question here, Linus, and that is what specific industrial use cases are you using, and what kind of data sets that the students will be able to work with?
Yeah, as we heard, I come from mostly the maintenance sector, so maintenance is one of the bigger challenges here. So maintenance itself, part of them are from the automotive industry, because we have their publicly funded research project where we are allowed to use the data for. We have also data from there's a pallet factory in Vienna, from TU Wien, where we have a lot of data from real machine data, where those manufacturing machines, for example, did run in certain problems, and we will learn how to predict those problems. We will learn how to forecast the remaining useful lifetime of those machines. And there are also autonomous vehicles there, bringing material from place A to place B. And we will learn how to optimize the ways between those vehicles, for example, see which route cannot exist from a realistic point of view, where are outliers in our process, and therefore forecast, for example, delivery times. So therefore, we will look into supply chain analysis. We will look into energy efficiency from real-world machine data, because we have the readings from machines, we have the energy consumption, and therefore we can use it, for example, to forecast the energy prices for us if we have them, or we can even go in and use this for maintenance in order to see, we have the machine data of the machine itself, for example, vibrations plus the energy consumption. And if vibrations and energy consumptions go up, we know we run probably into a fault. That's now a very simplification, but we will look into those real world data and together, build models and optimize them. Same goes for the factory planning. My colleague Julia Reisinger, who will present it, they have a lot of research projects in the area of factory planning and 3D model generation based on, for example, sketches. So she will bring a lot of examples from her research projects and industry projects, which you will learn to work with.
Great, Linus, we have still so many participants here. However, I don't get any more questions. So just a reminder, if you have a question for Linus, put it in the Q&A, put it in the chat, or raise your hand and you can talk to him right now. You know, this is your chance right now at the moment to speak with Linus, and there's one coming up. No, it's still about the payment methods. Obviously, there are no other questions right now. I I assume that we're gonna share your presentation on the website so people can download it. There's your email address on there, so if people want to get in touch with you, then they can do so directly. Do we have any other question? This is the chance, ladies and gentlemen.
Yeah, I'm really looking forward to your questions. And
there's one more. Competitiveness questions. Where are we ahead in the EU?
Sorry, where we are ahead in the
competitiveness question. Where are we ahead in the EU? So I think what he means, what Natalie, I'm sorry, what she means is, as far as AI, how competitive are we as a, part of the, in the European Union? I know there's a lot of discussions of AI development in the United States and China, and a lot of comparison between, those three blocks. How do you see that? How do you?
Interestingly, the area of natural language processing, even though OpenAI, which is more famously known, is from the US, or Meta and stuff like that, there is a company called Aleph Alpha in Germany, which is very interesting, let's say, competitor to them. But what makes them interesting, especially from a European perspective, is those models can work on premises, which is a big factor for, especially for European industry, who do not want to give their data to any American company on their servers, just the EU data protection laws here. And if you take traditional natural language processing, there are two main libraries out there, and one is from Germany, which is Spacey. Great to work with. I'm personally a big fan of it. And they have also a lot of tool sets around them. So like from the area of natural language processing, where I'm very into the practical part, we are very good in the European Union, especially, I believe, artificial intelligence with a focus on application in industry. That's our strong point. Probably in the consumer part, I believe the US and especially China are ahead of us. But application to industry, that's where we are strong, because we have a lot of high-tech industry here in Europe. Let's look at Austria. And yeah, that's where we also develop very niche solutions. There is a great, let's stick to the knowledge graph, supply chain risk forecast. There's a great Austrian company. They do exactly that. Yeah, I believe we have great AI niche products. In contrast to big OpenAI or Google, we don't have those, probably SAP, but we have great niche products where people sometimes don't know they are from Europe, what we call in the German-speaking area hidden champions. That's where we are strong, I believe.
Very good. Thank you very much. If you want to know a little bit more about AI in the context of Europe versus United States versus China, we have done some analytics on that as EIT Manufacturing. Go to our website, look it up. You can go to our community page, which is Agora, and you will find some of the analytics there. If there are not any other questions, then I thank you, Linus, for a very inspiring and great presentation. Thank you very much. I thank all the participants for their interest, and we're gonna hope to see you in one or more of the upcoming trainings. I think it's very en vogue. There's a lot of opportunities, job opportunities out there. So if you guys have an interest in working in data science, then this is the course for you. Thank you very much, and have a great day. Thank you very much, Linus.
Thank you.
Take care. Bye-bye.
Bye.